Hello. HighByte Intelligence Hub is often used to obtain data from Pi System, curate a use case aligned data payload, and send the data payload to a cloud data lake or data warehouse. The data payload might include real-time data, historical time series data, and even configuration data from Pi Asset Framework. And the data from Pi System might be combined with data from additional data sources to create a composite data payload. In this video, I'll cover just a simple solution where we're creating in the cloud a light historian based on data from Pi. And here you can see in Pi System Explorer, I've created an asset structure using Asset Framework, and each asset in this simple asset structure has a asset attributes associated with it. Next, I'll move to Intelligence Hub. And what I've done in Intelligence Hub is I've created a pipeline, and this pipeline is sending data to Pi. This is the attribute values. And first, before I show you how I use this pipeline, we'll go to the connections that are used in the pipeline itself. So I'll move to my connections, and this is a specific connection. In my overview connection tab, I've already created a connection to the Pi system. I'm using the Intelligence Hub Pi agent that's been installed locally, and I've authenticated that Pi agent with a self-signed cert, and I'm also using my Pi credentials here to log into the Pi system. I've created two important HighByte Intelligence Hub Pi connection inputs here that I'll use. One is obtaining asset metadata for all assets derived from this Pi well template. And when I run this query, you can see that for each asset, I'm obtaining all of the configuration related attributes. So that's my configuration data. I also have runtime data, the actual values, and I'm subscribing to those. So what I'm doing is I've created a subscription. So again, I'm using that well template. And at any time, any asset attribute that's associated to any asset that's been derived from that well template, anytime a value is inserted, updated, or deleted, I'm subscribing and I'm capturing that value, and that's what you see here. So that's the data that I'm going to be obtaining. That's the real-time data that I'll be sending to the data lake along with the metadata. I also want to make sure that I'm defining the schema, the model that is being used. So for the assets, I've defined a model here that has some of its contextual information that you might expect related to an asset. I also have a model for the attributes, description, data type, some of the attributes associated to Pi points, and I have a model for the data itself, just what you'd expect. Value, quality, timestamp, the data type, and just some light context that I can then use to look up in the other tables that I'll be creating. So I use a pipeline to do all this. The simplest pipeline, I have my asset data, and what I do is I obtain that modeled instance to model the data. I break up the data. I'm only sending the data on change, and what I'm doing here is sending it to a Snowflake table and also to two files. And this is important because this asset data is not changing very often, and I can use this on change stage in my pipeline to ensure that this pipeline might run relatively frequently, maybe a few times a day, but I'm only getting the data when it changes, and I can query that data here. I have my asset metadata in Snowflake, and you can see it's that structure that I've previously created, the data schema that I previously created in Intelligence Hub, and it's the asset ID, name, template that's been derived from path and things like that. So I also have a pipeline for the attribute metadata, and here it's a little bit more complex. We have as data moves through Intelligence Hub, it's a JSON, and I need to break up a JSON object and then break up an array. And here I'm mapping into my model that I previously defined, all those attributes that I've defined in my model. And ultimately, I'm sending that data only when it changes to Snowflake and to file storage as well, the data lake. And my attribute metadata here is viewable in Snowflake in a table, and I have the asset ID, attribute ID, attribute name, and description. And I'm actually capturing the values, the static values for values that are not associated with PyPoint. There I'm capturing those in this table. And then finally, what we're really interested in is the data itself, the values as they change. And I'm subscribing to those, of course, as I've mentioned, so I'm not missing any data. Every 30 seconds or whatever interval I determine is optimal for polling, I get that data that I've subscribed to, and that moves through this pipeline. It comes in as an object, I break it up, I check to determine what type of value it is. I could be looking this up, but I'm just doing something really simple here. If it's a number, I assign it double if not a string. I model it using that model that I previously defined, the schema that I've defined, and then I send it to the data lake or Snowflake. The Snowflake connection is really easy. It's configurable. I just define, the credentials for Snowflake. I define the table that I want to write to, the table name. I can create that table right from Intelligence Hub, and it's all configurable, as are the connections to the data lakes as well. All configurable. I configure the file formats and things like that. So this file, this table is getting updated much more frequently, and it has a significant amount of data in it that's accumulated. And I'm keeping this data table pretty narrow. Like I link, right? I just have an asset ID, an attribute ID that I can link, point ID that I can link to point context, the value, data type, and the value quality timestamp like you'd expect. So that is a quick summary of how Intelligence Hub can be used to create tables and also files. Everything that you've seen, I'm also writing to a file in AWS S3 and also to a file in blob storage. And that's how Intelligence Hub can be used to obtain data from Pi, structure it exactly how you'd like, and send it to a data warehouse or a data lake. Thank you very much.